in my eye. Hey everybody. This is day 19 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's part. And also today's video. Here I am in Norway. Yeah, just enjoying Norway in this temple. Yeah, let's get back to the problem. Yeah, day 19, let's go. Hit all the like buttons while this is loading, subscribe buttons, join me on Discord so we can always chat. I'm still here in, where am I? Osaka. So yeah, just kind of waking up at the crack of sunrise, or even before that. But yeah. Alright, today's problem is 1887, reduction operations to make the array elements equal. Given an integer array nums, your goal is to make all array elements in array in nums equal. I cannot read. Or elements in nums equal. To complete one operation, follow these steps. Okay, find the largest value in nums. Okay. Let its index be I and its value be the largest. Okay. Pick the smallest I. Okay. Find the next largest number and then reduce it to the next largest. All right, let's take a look at what that means. Strictly smaller than largest. Yeah, that's what I thought. Okay. Okay. I that's what I thought, but I thought it was a little bit awkward the way they phrase it, so I wasn't sure. Okay. So then what was the problem? Number of operations. Okay. So this is a simulation problem, right? There's no there's really no decision, right? That's what I was looking for. Meaning that there's no choice, you have nothing to do. Your entire goal for this problem is simulation and then maybe make an optimization. And of course, if you do this naively, meaning if you actually just run a simulation and then you do a loop every time, reduce every time, well, what happens, right? Well, the worst case is going to be, I think they kind of example 3 is almost that, but you're just going to have 1, 2, 3, 4, 5, 6, 7, 8, or something like this, right? Or just when all the numbers are not equal. When all the numbers are not equal, you could always re-indexed anyway, so, or re-normalized. So it's about the same idea. But then now it goes to 1, 2, 3, 4, maybe 7, right? And then now it takes 2 moves to kind of do this, right? So now it takes 1 move to do this, and then 2 moves to do this, and then and you guys see the pattern very quickly. That is 1 plus 2 plus 3 moves plus 4 plus 5 plus 6. I don't know if it ends at 6 or 7 or 8, but probably 7. So, but this effectively, if you simulate this one at a time, will be n squared, right? So you want to do slightly better than that, or a lot better than that, really. The idea about doing better, yeah, if you do it in n squared, it'll probably be too slow. I actually forgot about the n. Okay, yeah, the n is 5 times 10 to the 4th, so it'll be too slow. So how do you optimize this, right? Well, in the way that we kind of, well, one is just try to figure out if, there's a pattern. And of course, we kind of see the pattern kind of quickly, right? So then the problem, or the tricky part about this one is that, it's not always going to be just like a simple the summation from 1 to x or whatever it is. The idea here is that this is the worst case, but a tricky case, which is not necessarily the worst case, maybe just a lot of, dupes, because then now it takes 3 plus and then 6, right? Because now after after doing 3 moves, you have something like this, and then now you have 6 moves to kind of reduce it all to 1, right? So, I mean, and then you kind of get the pattern, and it's not so bad. So I think we can just do it. Basically, do the largest number every time. And yeah, and there are a couple of ways you can kind of think about doing it, right? But all of them will require in some form sorting. Right? Maybe it doesn't have to be an n log n sorting, maybe. I don't know if heap works, but heap will work. I don't know that it makes it more optimal. So, but yeah, but if you sort, it'll be okay. And then after you sort, maybe even do a reverse is equal to true, just to sort it in a reverse order, right? And then now we have, what's it called? Operations 0, 0. We return operations. right? And then now for, you could probably combine this in a lot of different ways. The way that I would just do it is just for I x in enumerate nums, or maybe just like for I in range of n. So we know that the first number, right, n minus 1, maybe that's a little bit easier. Depending on how you want to write it exactly, really. I mean, I think one way you can say is that you can reduce a number, but you can also think about it as previous numbers reducing it to this number, right? So, okay. So then now, I mean, it's going to be one way or the other. It's either writing this or this, but, you know, depends, right? So basically, if num sub I is not equal to num sub I minus 1, because that means that if the numbers are the same, there's no reduction, then you reduce all the numbers from num sub 0 to num sub I minus 1, all of them, you change it to num sub I, right? So change all numbers from num sub 0 to num sub I minus 1 to num sub I. And of course, how many operations does that take? That takes exactly I operations. Is it I or I plus 1? No, it's I operations, right? From 0 to I minus 1 inclusive, they're I numbers. And that's pretty much it. I mean, obviously, this is a... I mean, I think this is one of those problems. I mean, I say this often, at least for Leetcode, right? Which is that, you know, you look at the solution and you're like, oh, okay, this is obvious, you know? But I think I tried to go over all the... maybe not super detailed, but a good enough detail on how to kind of come up with it, you know, specifically. Because I think one thing that people... especially online, on YouTube, or whatever, people may make it sound easy. And I'm not gonna lie, I don't think this is hard. But when you look at the code and you're like, oh yeah, of course it's easy, it's a for loop. I think that's a fallacy. You have to kind of really make sure that you understand what you're doing and following each step of the way, right? If you understand it, of course it's easy. If you don't understand it, then, you know, maybe not so much, even if it is just a for loop or two and a sort, right? So definitely don't you know, figure out what it is that you're missing from that understanding, and then try to kind of get to it. I mean, because, you know, solving this particular problem, it's fine, right? Like, you know, maybe you can, maybe you can't, I don't know. But for me, the way that I want to kind of go over it is not necessarily solving the problem at hand. I mean, obviously, it would be very nice, but in a way, kind of like I want to demonstrate more of the thought process. I mean, I don't always succeed, so my fault if it doesn't. But I want to demonstrate more of the process so that, you know, so that, man, I cannot English today. So that you can basically solve similar problems in the future, or even more difficult but of a similar nature in the future, right? Anyway, that's all I have for today. Let me know what you think. Stay good, stay healthy, to good mental health. Did I do the time? I mean, I think I did the time. I don't think I did, actually. This is n log n and O of n space, O of n, because I count this, I count sorting as O of n because no reasonable API operation should you know, take the input and then change it in a weird way. I guess it's not a weird way, but it's just in any way. So I counted, like, if I were to actually make this an API, I would maybe do something like, you know, this to kind of copy the space over, so that when you sort, you know, it doesn't affect the original data. All right. Anyway, that's all I have for today. That's all I have for this problem. Let me know what you think. Stay good. Stay healthy to good mental health. I'll see y'all later. Take care. Bye bye. Today's ice cream, wet bean ice cream. Yeah. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about, you know, today's video, today's problem. What is this loudness going on at 11 p.m.? I'll see y'all soon and take care. Bye bye. Oh yeah, stay good, stay healthy, to good mental health. And yeah, I'll see y'all soon and take care. Bye bye.